Dear students, today we are going to start a new topic, and that is about question answering system. Till now what we have seen is text-based searching, wherein you give a query and what all documents are pertinent or relevant to those text strings, they are simply pulled back and presented before you. But what about a case when you have a question that needs the answer? So that is what question answering systems are all about. And more so, we are going to talk about fuzzy logic based question answering system. Why the emphasis on fuzzy logic based? Because the usual question answering systems are nothing but text based search systems only. What they do, they take the question, pick up the text from those questions, match it with the index of the web search engines and present the results before you. So they are essentially just doing the text mining of the question also, in addition to doing the text mining of the websites. So they are, strictly speaking, not the question answering systems. The question answering systems, they should have some deduction capabilities. What do I mean by deduction? Let me give you an example. Suppose I give a proposition that the distance between New York City and Albany is X miles, right? Now, if somebody asks a question, what is the distance between New York City and Albany? You can simply pick up the text strings, match them and say the answer X miles. But what if I give you a proposition which says that the largest city of New York State is New York, and the distance, there is another proposition, the distance between New York City and Albany is X miles. Now, if there is a question which asks, what is the distance between the largest city of New York and Albany? So now you have to do the deduction. You have to deduce the answer. First, you will have to see what is the largest city. You will have to form the question yourself. Which is the largest city of New York? The answer is New York City. What is the distance between New York City and Albany? X miles. Now let us take it to two level of deduction. The proposition, there is another proposition which says the capital city of New York State is Albany. Now the question is, what is the distance between the largest city of New York and the capital of New York? Now you have to do two level of deduction. First, you have to see what is the capital of New York. Then you have to see what is the which is the largest city of New York, and then what is the distance between New York City and Albany. Then only the answer could be deduced, right? So that is a question answering system with deduction, which is an inherent part of fuzzy logic based question answering system. And there is more. As we will see during our discussion, the fuzzy logic based system, they talk about approximate questions also. Okay. For example, if somebody asks, which is probably the largest city of New York? Now this probably, and such kinds of words, which can find a narrative only in fuzzy logic domain. So that is where fuzzy logic based question answering systems, they become more pertinent. So in essence, a question answering system should not just be a text based search system. It should have deduction capabilities and it should be fuzzy logic enabled. With this narrative and with this assumption, we are proceeding to discuss the fuzzy logic based question answering system. Now the outline of this presentation would be a conceptual structure of PNL is described. What is PNL? We will see. This is pre-associated natural language. Natural language by its very nature is imprecise. Today is a warm day. Now this warm is imprecise. Is it 30 degrees Celsius? Is it 35 degrees Celsius? Is it 40 degrees Celsius? Remains to be seen. right? He is a tall boy. So that this tall is imprecise in nature. I'm driving very fast, imprecise in nature. So natural language by its very nature, by its very inherence is imprecise in nature. So we need to do some precisiation process. So precisiation means making precise what is imprecise otherwise. Okay. So precisiated natural language is described. PNL's role is outlined and illustrated by examples in three domains: knowledge representation, deduction, concept definition. There are three very important areas of machine learning. How do you represent knowledge? We'll take the help of PNL. How do you deduce? The example of deduction I've just now given. And how do you define concepts? Giving the very definition itself is very challenging in the machine learning domain. To define a concept is even more challenging. How do you define a concept? So we are going to see the PNL's role in these three important domains. What should be understood is that PNL is in its initial stages of development. The exposition which follows, the discussion which follows, is an outline of the basic ideas which underlie PNL rather than a definitive theory. It's not a definitive theory as yet, but it has been developed on these lines and has been published in literature. So that is why we are discussing the importance of PNL, particularly in the domains that I've talked just about. This deduction, all these knowledge representation, deduction, concept definition, they are playing a pivotal role in question answering systems. Natural language is imprecise in nature, as I said. A natural language, in short, NL, is basically a system for describing perceptions. Perceptions of distance, height, weight, color, temperature, similarity, likelihood, relevance, and most other attributes of physical and mental objects are intrinsically imprecise. By its very nature, by its very build, they are imprecise. When we talk about distance, we say long, short, right? Very short. When we talk about height, high or short, like that. Weight, obese, slim, thin, right? Color, fair. What is fair? How do you define fair? Dark. How do you define dark? How do you define wheatish? Temperature, as I gave the example, warm, hot, cold, cool. What is the differentiation? Similarity, I'll say very similar, somewhat similar, dissimilar. What does that mean? Dissimilar, does it mean zero similarity? Not necessarily. Maybe very low similarity could also be categorized as dissimilar. Likelihood, it is very likely, it is, it is likewise. You can go on adding all the adjectives. Okay, it is somewhat likely and so on. Relevance, likewise, just as similarity, relevance is also. And most other attributes of physical and mental objects are intrinsically imprecise. So we are trying to make them precise. Why do you want to make them precise? So that they could be computed. A computer doesn't work on imprecise information. Let me give you a very basic example. Recall the very first lecture in your algorithms course. What was taught? Algorithm has to be non-ambiguous. Algorithm cannot be ambiguous, right? So there is no place for imprecision in the area of computer science or computer processing. When you are writing a computer program, you cannot say take a few steps and loop back. You cannot say that. You'll have to tell, take 6 steps and loop back, or 7 steps or 4 steps. You have to tell precisely. You cannot say take a few steps and loop back, right? So in order to make the natural language computable, we have to make it precise, and that process is called precisiation, right? So precisiation of natural language. How can a natural language be precisiated? What do I mean by pre-associated? Pre-associated in the sense of making it possible to treat propositions drawn from a natural language as objects of computation. Suppose I'm teaching you guys offline in a class. There is a student sitting at the back of the row. If I address him and say, take a few steps forward, that student will stand up, will gauge the distance between him and me, and will take 4, 5, 6 steps forward. I never told him 4 steps, 6 steps, but it is in the very human intelligence that he will gauge the surrounding, he'll see the size of the room, he'll see the distance between him and me, and then take some steps. He takes a decision on how many steps he has to go. A computer miserably fails. As I gave the example, take a few steps and loop back, the computer will miserably fail. Tell me 6 steps, 7 steps, how many statements I have to take before I loop back. Okay. So pre-associated is the sense of making it possible to treat propositions drawn from a natural language as objects of computation. This is what pre-associated natural language attempts to do. Pre-association is accomplished through translation into what is termed as pre-association language. In the case of pre-associated natural language, the pre-association language is the generalized constraint language, which we will see. So just GCL will be a tool for making the pre-association of a natural language. So that is why it is important. It is important that we discuss the generalized constraint language. GCL is a language whose elements are so-called generalized constraints and their combinations. We must note that what distinguishes GCL from languages such as Prolog, Lisp, SQL, and more generally, languages associated with various logical systems, e.g. predicate logic, modal logic, etc., is its high expressive power. So GCL has got a higher expressive power as compared to these languages that we see. We can call them as AI languages or simply logical systems languages. Right? So we will see what are the advantages of GCL and how does it help in pre-association as we proceed along our discussion. Before we proceed further, these are two very important terms in the domain of fuzzy logic: partiality and granularity. Partiality relates to the fact that most human concepts are not bivalent, that is, are a matter of degree. Something that I've been emphasizing from the day I introduced fuzzy logic in my own way. I don't say that you didn't know fuzzy logic from before, but the way I introduced. Thus, we have partial understanding, partial truth, partial possibility, partial certainty, partial similarity, and partial relevance, etc., etc., etc. So, partiality, or more appropriately, let me call it graduation. Graduation and granulation. So let me replace partiality by more appropriate word, which is called graduation. You don't have 0, 1 steps. True, false, on, off, dark or bright. You have graduations. It goes from 0 to 1. It is true to a certain degree. It is on to a certain degree. Right? So that is graduation, the very essence of fuzzy logic. But then fuzzy logic also does granulation. Apparently, these two seem to be contradictory terms. Fuzzy logic integrates these two otherwise contradictory terms. Granularity and granulation relates to clumping of values of attributes, forming granules with words as labels, e.g. young, middle-aged, and old as labels of granules of age. So even though you have graduation, but still you are able to form clumps. Warm, hot, cool, cold, granules. You form granules even though there is graduation in it. You cannot say it is a hot day, it is a cold day. There could be things in between also. So graduation. It is hot to a certain degree, it is cold to a certain degree. So graduation and granulation are two very important essence of fuzzy logic. So fuzzy logic attempts to integrate these two concepts beautifully, these two contradictory concepts beautifully, graduation and granulation. Now, existing approaches to natural language processing, they are bivalent logic, based on bivalent logic, a logic in which shading of truth is not allowed. PNL abandons bivalence. Pre-associated natural language abandons bivalence. By so doing, PNL frees itself from limitations imposed by bivalence and categoricity. You are not limited to saying absolutely true and absolutely false, absolutely beautiful and absolutely ugly, absolutely intelligent and absolutely dumb. There could be grades also. Opens the door to new approaches for dealing with long-standing problems in AI and related fields. So that is why it is very important that we study PNL, because it abandons bivalence, which was the strong fort for NLP. So we have come out of that bivalent fort of NLP and we are trying to wander into the PNL domain. Now let us take some sample data. Ideal for the home or small office, Airway allows you to link a number of telephones, computers, and fax machines into a single system without any internal telephone wiring. The heart of the network is the controller. This provides the wireless links to the telephone handsets and sockets, data sockets, so. Now, sample questions. What is an airway? You can simply say, see, now you are doing text matching. This is how a typical question answering system will go. What is an airway? It will say ideal for the home or off airway, or up till this point it can go, right? So answer fabricated. This will also be included. This will also be included. Okay. What are data sockets? So you can say data sockets are whatever. Okay. How many handsets can I connect to one controller? Up to 16 handsets. Okay. What does the controller do? So you can go this much part. Okay. So you try to do the text matching and you try to give the answer. But that is not, strictly speaking, a good question answering system. Let me take a challenging problem or sample data now. I have just bought a new PC. Packard Bell, name changed. You know why I've changed it, right? And I've tried to install the BT broadband setup, so on, so on. So this may be a customer forum. This is the complaint. This is the response sample question. What error is being reported? What is the solution? What is Packard hell? Somebody says Packard hell. Then it should go and say, then no, hell is not what we meant. It is Bell, and then it gives you the answer. So a little bit of correction may also be allowed in the question answering system. Now take the most challenging one. I'm planning to drive from Berkeley to Santa Barbara with a stopover for lunch in Monterey. Fair enough. Now the problem starts. Usually it takes about 2 hours to get to Monterey. Usually it takes about also it takes about this about is also a problem. About 1 hour to have lunch. It is likely that it will take about 6 hours to get from Monterey to Santa Barbara. At what time should I leave Berkeley to get to Santa Barbara with high probability? Before about 6 p.m. You cannot process such a system without having pre-associated natural language. So let me say simplified version usually W is about 2, where W is Berkeley to Santa Barbara. X is about 1. X is lunch time. Okay. To get to Berkeley to Monterey is W. Lunch is 1, and then Monterey to Santa Barbara is 6. So this adds up. Z is W plus X plus Y is usually about 9. 2 plus 1, 3, 6, 9. So, but it comes with usually about 9. In fact, it should be usually about to the power 3, 9. Because everywhere it is usually about, likely about. nevertheless, even if it is usually about 9, it is still troublesome. About 18 minus z is what? Why 18? 6 p.m. means 18. So I'll have to do 18 minus usually about 9. High probability. So it all gets very problematic when we are dealing with the real natural language, where there are a lot of imprecise adjectives and imprecise qualifiers. Okay. So the information on one side, it could be measurement based, numerical. It is 35 degrees, Eva is 28 years old, probability is 0.8, and so on, so on. Plus perception based linguistic information. It is very warm. Eva is young, probability is high. It is cloudy, traffic is heavy, it is hard to find parking near the campus. Now you can also see the difference between these three and these three. These three are maybe measured, but there is no measurement for cloudiness. There is no measurement for heaviness of traffic. There is no measurement for hardness in finding parking. So perception based is not only difficult, but may get very difficult. Measurement based information may be viewed as a special case of perception based information. So this is a special case of perception based linguistic, because 35 degrees Celsius is a special case of warm. 28 years is a special case of being young. 0.8 is a special case of being a high probability. Just as we said when we introduced fuzzy logic is a generic case of binary logic, or a binary logic is a very, very special case of fuzzy logic. Now, computing with words is what we are slowly moving towards, and which is a very important concept in fuzzy logic. The primary objective of computing with words is mechanization of reasoning and computation with propositions drawn from a natural language. Just as we have seen, this one, about 18 minus z is what? Where z is usually about 9. So this is computing with words. Right? So a prerequisite to computing with words is precision of meaning of proposition expressed in a natural language. You need to make this usually about 9 as precise. You need to do precision of usually about 9 before we can proceed any further. So precision of meaning is the province of precisiated natural language. Informally, precision of a proposition P involves expressing the meaning of P in a mathematically well-defined form. So precision should be defining it in a mathematically well-defined form, because if it is mathematically well-defined, it could be computed. So in PNL, a proposition P is precisiated by expressing its meaning as a generalized constant, GCL, that I introduced in the beginning, and I'll discuss more about it. In this sense, the concept of a generalized constant serves as a bridge from natural language to mathematics. Natural languages to mathematics. It includes all natural languages. Every natural language has this problem. आज शायद मैं दिल्ली जाऊं, अब शायद कहां से आ गया. आज तो बड़ा गर्म दिन है. You speak in Hindi, you have got so many such imprecisions there. So natural language, there is a proposition given in natural language. When you do a generalized constant processing of it, it becomes a mathematical language. The concept of a generalized constant is the centerpiece of PNL. So that is why it is important that we learn GCL, or generalized constant. Precision of meaning, we must note, is not the understanding of meaning. I understood what you said, but can you be more precise? So this example tells you that it is not about understanding of meaning. It is much more than that. I understood what you said. आज मैं दिल्ली जाऊंगा, मैं समझ गया तुम क्या कह रहे हो, लेकिन सही बात बताओ, कितना चांस है तुम्हारा दिल्ली जाने का. राइट? सो आप समझने के बाद भी प्रेसिसिएशन चाहते हैं. So it is not just understanding of meaning. It is more than that. Use with adequate ventilation. समझ में आ गई बात? Adequate ventilation. What do you mean by that? Can you be more precise? adequate ventilation. Unemployment is high, I understand. That in fact is the slogan of every youth. Unemployment is high, but can you be more precise? What do you mean by high unemployment? Most Swedes are tall. समझ गया मैं आपकी बात, लेकिन tall से क्या मतलब है? Precise बताइए. 6 feet, 6.1 feet, whatever. Most Swedes are much taller than most Italians. समझ गया मैं आपकी बात, लेकिन क्या मतलब है आपका? कितना taller than Italians? Overeating causes obesity. अब पहले ओबेसिटी समझाइए मुझे, क्या है ओबेसिटी? ओवर ईटिंग बताइए, क्या है ओवर ईटिंग? समझ गया मैं बात. ओवर ईटिंग कॉजेज ओबेसिटी, आई एग्री विद यू, बट व्हाट डू यू मीन बाय ओवर ईटिंग? व्हाट डू यू मीन बाय ओबेसिटी? ऐसे ही कॉजेलिटी, रेलिवेंस, बेयर मार्केट, माउंटेन, एज, अप्रोक्सीमेटली 5, देर ऑल फजी कॉन्सेप्ट्स. देर ऑल फजी कॉन्सेप्ट्स. बेयर मार्केट, शेयर बाजार जो है, बेयर मार्केट, शेयर बाजार अच्छा जा रहा है, खराब जा रहा है. अब क्या मतलब अच्छे खराब का, है ना? ऐसी कोई चीज, माउंटेन है, माउंटेन से ये मुराद है आपकी, या माउंटेन से ये मुराद है, या आपकी ये मुराद है माउंटेन से? एज, एज से क्या मुराद है? हाउ शार्प एन एज, व्हाट इज द स्लोप ऑफ इट? और अगर वो कॉन्वेक्स है, कनकेव है, ये सारे कॉन्सेप्ट्स. Now, bivalent constraints are hard, inelastic, categorical. आदमी लंबा है, आपने कह दिया अब लंबा छोटा हो ही नहीं सकता. उसका रंग साफ है, साफ कह दिया आपने तो अब साफ हो गया. अब कोई इसके अंदर गुंजाइश ही नहीं बची, है ना? तो दे आर वेरी हार्ड, इन इलास्टिक, कैटेगोरिकल, एक पर्टिकुलर कैटेगरी में फिक्स कर देते हैं. जनरलाइज कॉन्स्टेंट्स ऑन द अदर हैंड हैव गॉट द फ्रीडम टू मूव अराउंड. और इसकी जनरल फॉर्म ये होती है एक्स इज आर आर. एक्स कंस्ट्रेंट वेरिएबल है, आर, कैपिटल आर कंस्ट्रेनिंग नॉन बाइवेलेंट फजी रिलेशन है, और ये जो छोटा आर है दैट इज इंडेक्स ऑफ मोडालिटी है. इट डिफाइन सिमेंटिक्स. ये छोटा आर जो है वो बिलोंग टू, इक्वल टू, लेस देन इक्वल टू, ग्रेटर देन इक्वल टू, सबसेट ऑफ, सो ऑन सो ऑन सो ऑन. ये ब्लैंक भी हो सकता है, आप कुछ नहीं चाहते तो आप ब्लैंक कर दीजिए. प्राइमरली, है ना, वेरासिटी, यूजुअलिटी, रफ सेट, फजी ग्राफ, possibility sets and so on. It may assume any value and every value. तो ये जो है तो छोटा r, लेकिन इसकी पावर बहुत ज्यादा है, एक्सप्रेसिव पावर बहुत ज्यादा है इसकी. ठीक है, और x जिसको आप डिफाइन कर रहे हैं, और r जो उसकी डेफिनेशन है या जो उसका डिस्क्रिप्शन है, कैपिटल R. अब चलिए थोड़ा सा इसको, तो ये बेसिक, बहुत ही बेसिक चीज है एक्स इज आर आर. इसको दिमाग में रखिए. दिस वी आर गोइंग टू यूज ऑफन एंड ऑफन. x इज एन एनरी वेरिएबल. अब पहले x की बात कर ले कि x क्या क्या हो सकता है. x में भी एन एनरी वेरिएबल, x में इटसेल्फ भी अ प्रोपोजिशन, लेस्डी इज टॉल. x पूरा एक प्रोपोजिशन भी हो सकता है. x is a function of another variable, x is a function of y, x is conditioned on another variable, x is a structure, for example location of residence of Carol. X may be a generalized constraint in itself. X is a group variable. In this case there is a group जिसमें name 1, name 2, so on, name n. With each member of the group, name 1 associated with an attribute value hi of attribute h. Hi may be vector value. Symbolically ये group इस तरह से होगा, name 1, so on, name n. gh is name 1 h1, name 2 h2, name n hn. gh is a, right? So what is the membership value of h in name 1? So basically gh is a relation and gh is a fuzzy restriction of gh. gh is a is a fuzzy restriction of h. Example दे देते हैं, Swedes height is tall, right? ये पूरा x हो सकता है. Tall Swedes को हमने इस तरह represent कर दिया, Swedes height is tall, right? अब आते हैं आर की बात, जो हमने वहां पर लिस्ट तो कर दिया था, वी लिस्टेड इट देयर एंड देयर, बट व्हाट डू वी मीन बाय ऑल दैट? इक्वालिटी कांस्टेंट, x इज इक्वल टू r इज एब्रिविएशन ऑफ x इज इक्वल टू r. यहाँ पे छोटा r जो है वो इक्वल टू हो गया. लेस देन इक्वल टू इनइक्वालिटी कांस्टेंट, सबसेट हुड कांस्टेंट, ब्लैंक पॉसिबिलिस्टिक कांस्टेंट. x इज r, r इज द पॉसिबिलिटी डिस्ट्रीब्यूशन ऑफ x. Veristic constant, अभी example देंगे आगे, we will give the examples. X is veristically R. R is the verity distribution of X. Probability constant, R is the probability distribution of X. Standard constant, bivalent possibilistic, bivalent veristic, and probabilistic. Bimodal constant, random set constant, fuzzy graph constant, usuality constant, group constant. Let us give examples, things will be more clear. Possibilistic में X is R, probabilistic में X is probably R, veristic में X is veristically R. Primary constants are formalization of three basic perceptions: perception of possibility, perception of likelihood, and perception of truth. In this perspective, probability may be viewed as an attribute of perception of likelihood. Right? So, probability may be viewed as an attribute of perception of likelihood. सारी चीजें क्लियर हो जाएंगी, अभी एग्जांपल्स लेंगे हम. देखिए, पॉसिबिलिस्टिक की एग्जांपल ली, मोनिका इज यंग. क्या मतलब है इसका? मोनिका इज यंग का मतलब है एज ऑफ मोनिका इज यंग. राइट? मोनिका इज मच यंगर देन मारिया. तो एज ऑफ मोनिका, एज ऑफ मारिया इज मच यंगर. राइट? तो ये आर हो गया, यंग जो है वो तो आर हो गया, मच और ई आर ये स्मॉल आर हो जाएगा, और ये आपका पूरा एक्स हो जाएगा. मोस्ट स्वीट्स आर टॉल. तो क्या मतलब है इसका? आप काउंट कीजिए, tall sweets divided by the number of sweets is most. Right? So this is how you have to give a structure. Generalized constant language का structure लेकर आना है. देखिए, ये natural language है और ये structure आपने किया. ये natural language है और ये आपने उसका structure किया. ये आपकी natural language है और ये आपने उसका structure किया. In order to be utilized in GCL, generalized constant language. A probabilistic में X is normally distributed random variable with mean m and variance sigma square. जो एक random उसमें होता है, distribution में होता है. X is a random variable taking the values u1, u2, u3 with probabilities p1, p2 and p3 respectively. तो हम कह देंगे कि p1 है probability है, इस वैल्यू के लिए p2 probability, इस वैल्यू के लिए p3 probability है, p3 वैल्यू के लिए. एग्जाम्पल दें वेरिस्टिक का. रॉबर्ट इज हाफ जर्मन, क्वार्टर फ्रेंच एंड क्वार्टर इटालियन. पहले तो मतलब समझ लो इसका क्या. रॉबर्ट इज हाफ जर्मन मतलब अम्मा अब्बा में से कोई एक तो जर्मन है. क्वार्टर फ्रेंच क्वार्टर इटालियन का मतलब जो दूसरा पेरेंट है उसका एक पेरेंट जो है वो फ्रेंच है और एक पेरेंट इटालियन है. ये मतलब हुआ एथेनिसिटी. दिस इज कॉल्ड एथेनिसिटी. तो एथेनिसिटी ऑफ रॉबर्ट इज 0.5 जर्मन. वेरिस्टिक आ गया यहाँ पे, वेरिस्टिक कांस्टेंट. 0.5 जर्मन, 0.25 फ्रेंच और 0.25 इटालियन. फिर आइए, रॉबर्ट रिजाइडेड इन लंदन फ्रॉम 1985 टू 1990. कैसे करेंगे इसको वेरिस्टिकली? रिजाइड रॉबर्ट लंदन इज वेरिस्टिक 1985-1990. तो जो चीज ये नेचुरल लैंग्वेज थी, ये आपने उसको स्ट्रक्चर किया. ये आपकी नेचुरल लैंग्वेज थी एंड दिस इज हाउ यू स्ट्रक्चर्ड इट आउट. अब नाउ वी विल गो ऑन टू डिस्कस द प्रेसिसिएशन प्रोसेस, बट आई विल स्टॉप हियर. I'll stop here and I'll continue in the next lecture how actually the precision process will proceed. Thank you very much.